So there are two components to this security, an annuity and a single payment. First, let's find the value of the annuity. There are 40 6-month payments, so our periods will be in 6 months. So when we enter our periods in for N, we're going to put in 40 because again, one period here equals one 6-month interval. The effective 6-month interest rate is given as 5%. So since our periods are in 6 months, we can just put this in as our interest rate, 5%. Payments of $45 are made every 6 months, so our payment is $45. We can now find the value of this annuity in year 0. And we find the present value, what we would be willing to pay for it, so it's a cash outflow, we see is $772 and 0.1587 cents. Now let's find the value in year 0 of the payment, the lump sum payment, which occurs in year 20. Let's keep the periods as 6 months since the question gives us the effective 6-month interest rate. There are 40 6-month payments between year 0 and year 20. So again, we input 40 for N, the number of periods. The 6-month interest rate is still 5%, so we enter 5% in for the interest rate. The payment in year 20 is for $1,000. And so since we're trying to find the present value in year 0, this $1,000 is going to be our future value. So the present value, which is again in year 0, of this single payment that we get in year 20, at the end of the life of the security, is going to be $142.0457. And again, our calculator reports it as a cash outflow, a negative value, because that's what we're willing to pay for it. And that's just because we put the future value as a positive value, what we would receive. So how much would we be willing to pay for the entire security today? Well, the total value is just the total value of the annuity plus the total value of the lump sum payment. We found the annuity to be worth $772 and the lump sum payment to be worth $142. So the total value, what we'd be willing to pay today for this security, is $914.20.